Hello, my name is Sharoz Nasir and I am going to explain how I solved the complex computing problem for our operating system course in fall 2024. The task was to estimate by using the Maclaurin series for ARC10 and implement it using parallel programming techniques. So we have broken it into steps. So I will tell you according to the steps. Step 1 is understanding the problem. First, I analyze the problem and solve the formula for it. This is an infinite series, but we calculate it using a large number of terms greater than 1 lakh as specified in the assignment. Now, moving on to step 2, which is approach and design. I designed the solution using a multi-threading technique for parallelism. The program divides the series calculation into smaller tasks, where each thread calculates a portion of the series. I ensured that the work was evenly distributed among threads to avoid overloading any single thread. Now moving on to step number 3, which is implementation details. So in implementation details there are two versions. Number 1 is single flow, which is sequential, also known as sequential code. This calculates pi step by step in one thread. Now there is one more thing, which is parallel version. Using multiple threads, each thread processes part of the series and updates the global result using mutex locks to avoid race conditions. Now from here my group member Mohammed Ahmed will continue.
Hello, how are you? My name is Muhammad Ahmed, and from further on, I am going to explain you about this my assignment. So, now moving on to the our step number 4, which is challenges and synchronization. I used mutex locks for synchronization to prevent errors when multiple threads updated the global result. This ensures data integrity. Additionally, I tested for edge cases and fine-tuned the implementation for efficiency by minimizing idle time for threads. Now, for step number 5, which is definite results and analysis. I ran the program for various values of n and observed the execution time for both sequential and large values of n. The result showed that the parallel version was significantly faster, especially for large values of n, as it utilized multiple processors effectively. For now, it's time for the conclusion. Let's summarize it. I approached the problem by dividing the work into submodules, synchronizing them with mutex locks, and analyzing the performance to ensure an efficient and accurate solution. So that's